my young geometry students. Hate to tell you this, but this is part B of lesson 1-3 on points, lines, and planes. It's very important that you understand the concept of postulates. So these are the 4 basic postulates of geometry. I want to remind you that in your vocab packet you should have written that a postulate, right here, this is their definition, is a statement that is accepted as being true. It does not need to be proven true, just accepted. It's true, and we're okay with that. Alright, what I want to do is show you how to draw pictures of the 4 postulates that you should have in your vocab packets. And I'm going to say that I'm going to use the terminology we used in part A of this lesson. And so watch carefully. If I seem to be going too fast, then just pause the video and rewind it, and you can listen to it one more time. Alright, postulate 1-1 says through any 2 points there is exactly 1 line. And so what I'm going to do is draw 2 points, and I can draw the 1 line going through those 2 points. And don't forget the arrows on the ends of your lines. So through those 2 points I did indeed draw a line. Now one thing I did not mention in our last video is that you can name a line also by 1 lowercase letter. So I'm going to choose to name this line N, and I'm going to use points A and B as my 2 points. Don't forget, use capital letters to name points. So I can say that line N contains points A and B. So through any 2 points, there's exactly 1 line. Great. Postulate 1-2 says if 2 lines intersect, then they intersect at exactly 1 point. This word intersects. Intersect means to cross or to touch. So if I draw 2 lines, then where they touch should be exactly 1 point. So I'm going to do that. I'm going to draw 2 lines intersecting at exactly 1 point. So here's what this postulate looks like. Here's my first line. Let's call this line L. And I make my L's like a cursive L, script, lowercase. Here's my next line. Let's make this line M. I also make it a lowercase script. And indeed, these lines did cross. Now, if 2 lines cross, even though you don't see a big blobby point, if they cross, then you know there's going to be a point there. So let's call that point X. X marks the spot. Okay, so I have shown in this picture 2 lines intersecting. And so I can say that lines M and L intersect at X. So remember, you name a point with a capital letter, and just for reference, this is called the point of intersection. Point of intersection. Right there. Okay, this next postulate is actually a little difficult to try to draw and comprehend. So actually what I'm going to do is I'm going to take this statement and I'm going to move it down a little bit to give us some room to draw this so you can see it clearly. Alright, postulate 1-3 says if 2 planes intersect, then they intersect in exactly 1 line. And I want to have you think about taking 2 note cards, 2 index cards, and making them cross through one another. Okay, I'm going to try to draw that. And I will demonstrate that in class tomorrow so you can see what I'm talking about. All right, remember when we draw planes, When we draw planes as parallelograms. So I'm going to draw a parallelogram. Okay, this is my first plane. Now, in order to draw a note card going through this, I'm going to draw parallel to these end lines a line. That's my first step. Going straight up and down vertically, I'm going to draw one line going up, straight up from this point. And from this point of intersection, I'm going to have a line identical to it, congruent, as we say in geometry. Parallel, so I'm going to make a line parallel. I'm going to do the same thing going down from this point, down from this point, parallel. Now this is supposed to show it. Now it's hard to see. I'm going to add some dashed lines to show a line is behind it, and I'm going to do some shading, use some color. So the first thing I'm going to do is I'm going to color in this plane. It's going to help us see our intersecting planes better. Now this is going to go underneath. And because this is passing through, I'm going to make these dashed lines. Now, this is really kind of hard to see still, so I'm going to use a highlighter. I want to highlight the other plane. Hopefully, with the color, it stands out more and you can see two planes intersecting. All right, so where are they intersecting? Let's call this plane capital P, the yellow one. Let's call the red plane capital Q. So I have planes P and Q intersecting. Now they are crossing, they are touching. Where are they crossing or touching? They're touching here, 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 here. But this says it intersects in a line. I've only drawn a segment. So I continue it going this way, and I continue it going this way. I name this point and this point as my lines. And so let's call this point, I don't know, let's call this point X. Let's call this point Y. Intersecting at line XY. Now I want you to know that this point X is on both the red plane and the yellow plane. This point Y is both on the red plane and the yellow plane. And this is my picture of two planes intersecting in exactly one line. Okay, lastly, I want to talk about postulate 1.4. It says through any three non-collinear points, there is exactly one plane. And so what that means is if I have 3 points, 1, 2, 3. Now why did I draw them like a triangle? Because non means not, co means share, line. Not share line, says the caveman. Okay, so not share line. So I have to have a point. Let's call this point A, B, and C. Now, these 3 points are on a flat surface. So I can draw a plane around those 3 points. And this would be like having a flat piece of paper with 3 points drawn on it. And so any 3 non-collinear points, there is exactly one plane. So how would I name this plane? I would name this plane ABC or plane CBA. Remember, it takes 3 points to name a plane. So points A, B, and C are coplanar. Okay. All right, let me give you some examples of how you're going to use this. I want you to take a look at this three-dimensional drawing of a box. And I'm going to use my smartboard markers to mark on the box and erase them for each of these examples. And so if it would be more helpful for you to draw this box for each one, maybe you can see it, maybe you can't, but pay attention carefully. First question says, what is the intersection of plane HGC? I'm going to take a highlighter and I'm going to highlight H, G, and then C. And don't forget, you always want to make a parallelogram. So if I connect it as a parallelogram or a rectangle, what in the world did I shade? Well, the top of the box is the purple. The front of the box is the green. What's the yellow? The back of the box. The yellow is the back of the box. All right, I'm going to choose another color. I choose red. I'm going to highlight plane AED. Here's A, here's E, here's D. Now again, I am going to connect them, and I want them in the shape of a parallelogram. What side of the box did I just highlight? I highlighted the left side of the box. Now, when two planes intersect, they intersect in a line. There's an intersection. What line contains both colors? What line contains the yellow and the red? Well, the line that contains both of them, let me erase these. The line that contains both of them is this line. Well, right here. Let me use a color. Pick a different color besides red. It was so dark. Let's choose orange. This is the line. It still looks like red to me. Okay, this is a line that contains both of them. So I'm going to say it's line HD. That's my answer. Now, take a look at this picture. You don't see a line. You see a segment. But according to the last postulate, when two planes intersect, they intersect in a line. So I need to make sure I'm using my line symbols. Okay, number 2. Is line AD coplanar? Remember, co means to share a plane. So is line AD lying on plane ABFE? Well, let's take a look. ABFE. A, B, F, E. Let me connect it to make my parallelogram a rectangle. ABFE is the green front of the box. The question is line AD lying right on top of that green box? Now, it looks like line AD is in the box, but I got a problem. Notice the line is dashed. Now, it could be solid outside the box, but it's dashed until I get outside the box. What does that dash mean? It means it's not part of that shape. And so because it's dashed, it is not coplanar with that front of the box. So the answer is no. Explain. Because the line is dashed and not solid. As it touches the box, touches the plane. And that is the reason why it is not coplanar. Okay, the last example. This one's going to be mind-boggling for you. It's hard for people to see 3D, so do your best. The question wants you to do this. Name a fourth point in plane CHE. A fourth point in plane CHE. Okay, what I'm going to do is I'm going to first find my points CHE. Here's point C. Here's point H, and here's point E. Now these 3 points determine a plane, and when we draw a plane, we want to draw a parallelogram, or a rectangle, or a square. So I'm going to connect these. Oh, I got a diagonal going down, and I have to make it parallel, so I'm going to draw another diagonal going down. Parallel. Now what did you notice happen? This plane is running diagonally, crossing through the inside of the box. What fourth point did it actually touch? Well, it touched this fourth point B. So the answer is point B. And yes, you will have problems like this in your homework assignment. Okay, this is it for Part B of Lesson 1-3. Thank you very much for writing down these notes. Don't forget, if you need to, stop and go back and review the video. You guys have a great night. I'll see you tomorrow.